Hello guys, and welcome to Unit 8 of our iGCSE Computer Science course. Unit 8 is our entry to programming and ties in heavily with Unit 7, where we try to develop our minds into being able to solve problems and think algorithmically. And we will put all of those skills together using the pseudocode that we've learned so far and learning how to solve these problems using lines of code and start our journey into programming. So at this point, you may well have used a programming language or have some basic understanding of how programming works, or you might have zero knowledge. But either way, I will teach this lesson to both types of students to make sure we understand exactly what is required when it comes to the exam in this course. So if you haven't already, I would recommend completing Unit 7 first, as I will be talking about pseudocode and programming simultaneously, and I'm going to try and join the two together. In this lesson, we're going to start with something nice and easy, which are variables and data types. And again, this is something that's briefly being covered in Unit 7, but we're going to go into specifics today when it comes to actual programming terminology. And by the end of this lesson, what I'd like you to be able to do is declare and use variables and constants. Okay, so we need to understand the difference between a variable and a constant, but we also need to know how to declare and use them in some kind of scenario. And then something that's really easy to understand is using these basic data types here. We have integer, real, char, string, and Boolean. So these 5 data types, really easy to understand, and that won't take us too long. So we'll start with that. And as you can see, we've got our 5 data types here. The first one being an integer, which is super easy, and it's a whole number. It doesn't have any decimal or fractional part. Some examples will be 5, -10, or even the number 0. So an integer is a whole number, and examples where we've used these so far in Unit 7 are for things like counting or even indexing when it comes to an array, or just generally whenever a whole number is required and we don't need the decimal part. So integer, super easy, and that brings us to a real, which is also known as a float. Okay, so it is good practice to know both terms. I'll be calling them a real in this lesson, but a real number is a number with a decimal point. So in examples, you've got 3.14, -2.5, or even 0.001. So if you are measuring something, performing complex calculations, or there's a scenario where you require a certain amount of precision, then you would use a real data type in order to store a number. Now, both of these data types are numerical, so whenever you are storing numbers in a program, you would use one of these 2 data types. The next 2 fall under the category of text or alphanumeric, and a char is literally a single character. Now, a single character isn't just a letter, it's also digits and symbols. So for example, you'd have the letters A or B, uppercase and lowercase, but you could also store the number 3 as a char, but you wouldn't be able to perform any mathematical calculations with this, as it's stored as what we call text. So for example, something like a password, which can contain numbers and text. We can store numbers in chars and strings, which we'll get to in a minute, but they wouldn't be able to be in any mathematical equations. And of course, symbols, such as a $sign or an exclamation mark, they are also classed as a char, but a char refers to a single or individual character. Okay, so only one. A string, on the other hand, is exactly the same, but will be used for multiple characters. So the word hello, or even a sequence of digits 1, 2, 3, 4, these can be stored as strings and are one of the most common data types that we will use in programming. So storing names, sentences, any type of text, you would use a string. And finally, Boolean, this very strange word, has only 2 possible values, and they are either true or false. So these will come in very useful later on in the course, but for now, let's just remember them as true or false, and we will come back to these in a later lesson. So when it comes to variables, the first thing that we need to do is declare them. Now, we do have to do this when we are using pseudocode when it comes to the exam. You also have to declare variables in certain languages as well. But in this course, we're only going to be using Python. And in Python, we don't need to declare our variables. We simply just need to create and store data inside them, which is fairly simple. But the term declaring just means that we create it and we get it ready to be used within the program. So when we declare a variable, we need to give it a name, and we also need to declare what type of data type is going to be used. So for example, here I've declared a variable called age, and inside this variable, it's going to store the data type of integer. So within my program, I'm going to come back and use the variable age and store some kind of number inside of it. In the next line, you can see I have declared a variable called name, and inside the name variable will contain a string. So these 2 lines here are what we call declaring a variable. So the clue's in the name, declare, capital letters. And then once we've created them, we are then able to put values inside them using our assignment statements from Unit 7. And we can put an integer inside the variable age. and we can put a string inside the variable name. So this part is called assignments or assigning values, and again, this was covered in Unit 7. The next term we need to look at is a constant, and a constant serves the exact same purpose as a variable. However, it contains a value that cannot be changed. Okay, so it constantly stays the same. So throughout the program, we create a constant value. We cannot change what's inside. The only way you can change what's inside a constant is within the lines of code before you run the program. Once you run the program or the program is compiled, you cannot then change the value inside. So as you can see here in pseudocode, we've got the word constant in capital letters, and the value of pi in maths doesn't change. So we can store this in a constant, as this value will never need to change. In the second example, I've created one called VAT, and I've put in the value 0.2. So if my program calculates the VAT of an item, this value doesn't need to change once the program is run. However, VAT can change in real life. So what we would have to do is we'd have to rewrite the lines of code within the program and then compile it again in order for that value to change. So if the value of VAT changed to 0.25, for example, in the real world, we'd go into our lines of code and we'd simply rewrite this line to contain this instead. But once the program is run, you cannot change the value inside. And another one could be the size of a class, and we assign that to 30. So if a school is storing data and there can't be any more than 30 students in a class, we could create this as a constant, as this value will never need to change. So constants will stay the same throughout the running of a program. Now, as I've mentioned, we're going to be looking at pseudocode and Python in this unit. Although Unit 8 is specifically programming, I would like you to be able to connect pseudocode to lines of code, as it will just help you understand the whole thing a lot more. Most of my students will complain about learning both, and I do understand the difficulties of this, but being able to translate pseudocode into Python is one, a skill in itself, and two, allow you to have a deeper understanding of the course and simply make you a better programmer. If you are struggling, just stick to one. Okay, so Unit 7, I've covered some pseudocode basics, and if you are finding it hard to connect the two, just stick to Python within this unit, but please try your best to understand how they connect together. So now we just want to look at these term input and output statements, again covered in Unit 7, and here you can see some basic input and output statements written in pseudocode, and I have asked the question in my program, how many times do you go to the gym per week? Once the user types in their response, this is stored in the variable gym sessions. So we input this value, input gym sessions, and we then multiply gym sessions by 52, and the answer to this equation will be stored in the variable sessions per year. I can then print out a statement saying in a year you will have been to the gym this amount of times, which will be this variable from here. So again, this is going back to Unit 7, but in this lesson, we need to, one, be able to write this in Python, and two, understand the different variables and data types that are being used within this simple program. So firstly, if we are asking the user to type something into a program, that would require two separate commands. It would require an output statement with the text that follows, and then it would require an input command with a variable next to it. So in pseudocode, these two lines of code are classed as two separate commands. Now in Python, this is combined as one, and as you can see here, the first name variable that I've just circled is followed by an equal sign, and then the input command with the brackets and the output statement inside. So all of this is combined into one line of code when we use Python. And this is why some students simply just prefer to use Python, but being able to connect these two things together will allow for that deeper level of learning. So if we just run this line of code in Python, I'm just using the very basic IDE provided by Python themselves. But if we run this code, we can see that the program stops after it's run and it's waiting for me to type something in. Obviously, I can't prove that this does anything yet, but we will come back to this later in the lesson. Now, in the previous example, I was asking for somebody's name, which if we think back to our data types, names should be stored as strings as they consist of text. Now, if our program needs to work with numbers because it's going to be used in some kind of calculation, then what we need to do is we need to use our previous knowledge of these two lines of code here in pseudocode and add a small piece of code in the Python program to make sure it knows it's working with numbers. So as you can see, output, please enter your age. Input age in Python would look like this. Age equals int input, please enter your age. So what we've done here is we've added this word int, which tells Python that the input needs to be stored as an integer. Okay, if we take away this int, the brackets and this bracket at the end, this looks very similar to the example we've seen previously where we simply asked for the input of the name. But here what we've had to do is add this word int and add an extra set of brackets around the end. So this is something that you will get used to doing. And even after many months of programming, there will be times where you've wrote a program that works with numbers and you'll come to a problem where the program crashes because it wasn't able to perform a calculation. And it simply could have been because you missed this term int on an input early on in the program. But like I said, this just gets the program ready and tells it that the variable here should be stored as a numerical value. And in this case, an integer is a whole number. So here you can see the similarities of pseudocode and Python. We've got these two lines of code here that can be written as 1 in Python. And then the output statement in Python, we would simply write as print with our output statement in brackets. So in pseudocode, we're not used to writing brackets on our commands, but in Python, you need to be. And as you can see, print UR in the speech marks, which we should be used to, followed by a comma, the variable name, another comma, and then the rest of the string statement. So if we just give this a quick test in Python, and I'll talk you through it, explaining what's going on at each point. As you can see, we create a variable called age. I then write the word int, followed by the input statement, and then the prompt, what I'm going to display to the user. So as you can see, int is turned purple, so is input, as they are command words within Python. I've got 2 open brackets, followed by the string statement, which I then close. And of course, I use the 2 closed brackets as I've got 2 open brackets because age is going to be an integer. Then I'm going to print out the age that I type in with the sentence, you are X amount of years old. And let's just give that a quick run. As you can see, we are prompted with the text that was green in our program. Please enter your age. The program is now waiting for me to input. I'll type in 25 and it prints out the statements, you are 25 years old. So hopefully you can see the similarities between pseudocode and Python, because trust me, once you get the hang of this, the exam, programming in general, and particularly units 7 and 8 within our course will become much easier the more and more practice we have when it comes to these 2 languages. So just to finish off, let's just recap and go over the 5 different data types used within programming. And then what I want you to do is declare 5 variables for these data types and put some kind of data inside of them. So pause the video, give it a go yourself, and I'll go over the solution shortly. And as you can see, we've got an integer, which is a whole number, a real or float, which has a decimal part to the number. We've got a char, which is a single character from the ASCII table. A string is multiple characters, in which we always use quote marks. And a Boolean will store the values true or false. And if I just declare 5 variables using these data types and assign them a value, I declare a variable called shoe size, and this will be an integer. I declare a variable called cost, and this will be a real. First initial, for example, could be a char. A greeting could be string. And then whether somebody is signed up to a website, we would class as Boolean, true or false. And then to put values inside of them, shoe size, I assign the value 10. Cost, I've put a price inside. First initial is 1 character. Greeting is a whole sentence. And then signed up, I can set to true. So they're just 5 very basic examples. And if I just quickly create these variables in Python, as you can see, I don't need to declare them. I can just simply create each one, putting a value inside using a equal sign as opposed to an arrow. So that's something else that you will get used to. Where we use arrows in pseudocode to assign a value to a variable, in Python, it's an equal sign and not an arrow. Okay, guys, so that's it for this lesson. If we just quickly go back to the learning objectives for this lesson, hopefully now you know what the term declaring a variable means. You know the difference between a variable and a constant, and you can start to use variables and know which type of data is stored inside of them, and hopefully be able to think which variable you would use in certain scenarios within a program. So as always, guys, thank you very much for watching, and I hope to see you in the next lesson of our programming unit. See you next time.